Hello everyone, my name is Suprina Mansang. Today we are going to teach you about square metrics. The topic we learned from lecture 8. And here is our member. And first of all, we will explain to you the definition and the properties of a square matrix. Then we will give you some examples. And next slide. So first, let A be a square n by n matrix. The minor of Aij, denote Mij, is the determinant of the matrix A with row I and column J removed. The cofactor of Aij, denote Cij, is minus 1 to the power I plus j multiplied by Cij. And the determinant of A is that of A is equal to AI1 multiplied by CI1 plus AI2 multiplied by CI2. And do this until the AIN multiplied by CIN for any row I. Or that of A is equal to A1j multiplied by C1j plus A2j multiplied by C2j. And do this until A and j multiplied by C and j for any column j.
Okay, let me introduce myself. My name is Thanakit Lutakut. From the adjoint of A is the matrix adjoint A equal Cij transpose. If A is invertible, A inverse equal 1 over ZA times adjoint A.
Next, let me introduce myself first. My name is Shakon Gatatip. So let A be an n by n matrix. The following statements are equal. So first, if you know one of this, you can conclude all of this. Everything are follows. At the first, if you know determinant A is not equal to 0, A inverse can find. And A has rank n. The reduced low echelon form of A is the identity matrix. Ax equal to 0 has only the trivial solution. Ax equal to b has only one solution for every b. And the row and the column of A are linearly independent and form span R to the n and form a basis for R to the n too. If you have one thing of this, you have all other too. And another thing is if you know that determinant A is equal to 0, you know that A inverse does not exist. And A has rank less than n. A cannot be ranked more than n because A be ranked n by n matrix. And for the rows and column are not linearly independent and are not span R to the n and not basis for R to the n too. And Ax equal to b can have more than one solution and no solution. So next is the example of determinant. And the first determinant of 2 by 2 matrix. First question, A equal to matrix A, B, C, D, and the second is A equal to 1, 2, 3, 4 matrix. Here it is solution. We can know that if we want to find determinant of A, we multiply A and B. We know that A and D, sorry. we know that AD is positive and we multiply B and C. Don't forget to take negative here. And determinant of A is equal to AD minus BC. And the second solution for the number, we can know that determinant of metric 1, 2, 3, 4 is equal to -2 from this. 4 times 1 equal to 4 and 3 times 2 equal to 6 and we get 4 minus 6 equal to -2.
Okay, from the determinant 3 by 3, for the first question, from the metric 3 by 3, we copy the first row and the second row, and we multiply down. I strike 5, 3, 1, so I get 15. I strike 2, 7, 4, so I get 56. I strike 0, 1, 0, so I get 0. All these numbers are gonna be positive. And I strike up 4, 3, 0, I get 0. I strike up 0, 7, 5, and I get 0. And I strike up 1, 1, 2, I get 2. The determinant of this 3 by 3 metric is gonna be 15 plus 56 minus 2. And that's gonna give me 69. And from the question 2, if you have an upper triangular matrix, meaning that you only have non-zero number in the upper triangular, the lower number is the all variable, same thing, would be applied here. That is the determinant of this matrix, would be just the product of the number that you see in the diagonal, so that would be 8 times 3 times 4. So that would be 96.
On this slide, me, Laksit Nelson, will describe you determinant 4 by 4. Next. First, we will choose one of 4 columns, and this situation we will choose this one because there is more zero. It will easy to calculate. After that, we will adjoin all number that we chosen column. And then we will put the number which we adjoin put down here or number. And don't forget to set the negative positive to the right. And then we will see there is 0 multiply on third and fourth. So we will got only 2 remain. And then put 1 power by its number position. For example, this 4, its position is from the first row and second column. So one power will be 1 plus 2. Also use same method with this section. Next, right? And this this line is easy. Use determinant 3 by 3. And in the end, we will got 65 as a number. Next is a property of determinants. From the question, if A and B are real numbers related with this metric is equal minus 17, what is value of this metric will be?
So me, myself, Natawat Tuangkwat, will explain how to solve this question. You can see at first we transpose and made R3 or row 3 match what the question asked. And since we transpose, so the value of the matrix doesn't change. You can see on the right side, we multiply the first column by 2. The depth will become twice as much. You can see on the left side on the second row, we multiply row 1 3 times, then switch it to row 2. It will become likely what the question asked. You can see on the right, on the third column, on the third row, we switch, since we switch first column to second, the depth will be negative. On the left third column, third row, you can see that we multiply row 1 by 2 because it make the similar to the matrix that the question asked. And since we multiply the first column by 2, the dead value of the matrix will be twice as much. And the last step is we add row 3 and row 1 together, and it will be the matrix that the question asked. Since this method will not change the determinant value of the matrix, so the answer will be 68. So thank you for listening and for watching our presentation. I just wanted you to see the beautiful face of Tan Pisit, and that's it, the end. Thank you.